Alright guys, so we are now embarking on our new unit on three-dimensional figures. We've made it past all the two-dimensional stuff, and hopefully at this point you've already watched the video of Emily and I sorting the three-dimensional shapes into different kinds of shapes, and you're ready to join us here with what it is to be a polyhedron and the different parts of a polyhedron. So what I want you to do is I want you to pause the video for just a second, and up here in this word bank I want you to use these four terms and make your best guess at which of those words goes in these four blanks. So it turns out that research shows that if you'll guess the answers before I tell you, you're more likely to remember. You're going to make more sense of it. So go ahead and pause the video real quick. And then we'll come back and check our answers. Okay, so what I hope you guessed on this first one is that a solid figure with all flat surfaces that encloses a single region of space is called a polyhedron. And what we saw in that video with Emily is that these are not circle-based shapes. They're things with flat sides. In fact, each side is a polygon, not anything circular. And so each side is called a face. I'm here drawing a face on my face. And then the line segments where the faces intersect are called edges, as we saw over here. We have an edge. And then lastly, where the edges, where the corners come together, are called vertices, or a vertex. So what you're going to do here on this first example is you're just going to determine whether this is a polyhedron or not a polyhedron. And that's it. That's all you're going to do, and then we're going to talk about why. So pause the video, give your best try on example 1, and then we'll talk about it here in a second. Okay, so this first one is a polyhedron. It has flat sides that are polygons, and it encloses that space. The second one, no, this is a cone which has that circle there at the bottom. Anything with the circle on it is not going to be a polyhedron. The next one, again, we got circles, friends, so that sphere is a no. And then the last one is a yes. Pyramids, things with triangle sides, are still polyhedrons, even though their sides aren't rectangles. Alright, so you watched the video with Emily and I where we classified the polyhedron. Let's go through and talk back through that classification philosophy. Okay, so as you may recall, Emily and I split up those three-dimensional figures into polyhedrons. These are flat, excuse me, polygon sides, versus these guys have circles. Sorry. And so the polyhedrons can be split into categories of prisms and pyramids. Okay, so the prisms, we said, have rectangle sides. And technically, keep in mind, they don't have to be rectangles. They're technically parallelograms, so we'll write that out in parentheses. We'll see that come into play a little bit later. But parallelogram sides, but right here they're rectangles, versus the pyramids have triangle sides, and they really are always triangle sides. These guys had rectangular parallelogram sides. And then the non-polyhedrons, we split those into cylinders, cones, and spheres. Three different kinds of shapes made out of circles. Now, if we were going to name, let's focus back on the polyhedrons, back on both the prisms and the pyramids. I want you to take a minute and think about what do they all have in common as far as like their last name, and what does each name of the shape have that's different in their first name. How would you decide how to name these? In other words, note that polyhedrons, or you can say polyhedra plural, are named by the shape of their blank. I hope you're thinking right now, well, look, Miss Benton, all these have prism for their last name, and then their first name, pentagonal, rectangular, triangular, that seems to be the shape of the top and the bottom, what we're going to call those bases. So we're going to say this is bases. Is that true also for the pyramids? Sure enough, triangular pyramid, here the bottom is a triangle, rectangular pyramid, the base is a rectangle, pentagonal pyramid, the base of this is a pentagon. So sure enough, that works for all of them. Just keep in mind the pyramids just have the one base with the vertex at the top versus the prisms have two bases, a top and a bottom. All right, so here we have a nice ACT practice problem. It says the pyramid above has a square base with an area of 100 feet square. So area is 100. Just keeping myself organized, and I'm also, since I know this is a square on the bottom, I'm going to go ahead and put tick marks on all four sides. If each edge from the top of the pyramid to a corner of the base is 13 feet long, what is the sum of the lengths of the 8 edges of the pyramid? All right, so if the edge from the top of the pyramid to the corner is 13, so that means here is 13, here 13, here is 13, and here is 13. So what we don't know, what is not given to us in this problem, is the bases of the square at the bottom. We have to figure those out for ourselves, and we can't just assume that they're 13. What we do know is that a square has two sides that are the same, or four sides, excuse me, that are the same length, and that this guy times this guy is going to, x times x squared we'll call it, is going to equal 100. How did you know that, Miss Benton? Over here I wrote down that my area, my length times width, my base times height was going to equal 100. So now what is my length and width? If I take the square root of both sides, what number times itself is 100? We get 10. So all these side lengths must be all 10. In which case, what are all the edges added up? All 8 of them? Well, we've got edges sum is going to be 4 times 13, because we have 4 of them that are 13 long, plus 4 times 10. So that 4 times 13, that's going to give us 52. 4 times 10 gives us 40. Add those together and we get 92. And that was feet, so feet. Remember, it's not feet squared. We're not finding area. It's just length, which would just be 92 feet, period. All right, so I'm going to pick up and meet you in the next video.